Hi everyone, my name is Enrique Ayala-Hernández. I am a PhD student from the University of Guadalajara in Mexico, and I'm going to talk about my work entitled A Mathematical Model that describes the protective effect of a plant extract mixture in cirrhotic rats. The content of my presentation is as follows. I begin with the introduction, then the mathematical model, the model fitting to experimental data, and finally, the conclusions. Introduction. Cirrhosis is defined as a disruption of the normal architecture of the liver with fibrosis and nodule formation. Is the end result of the chronic liver injury. In the congenital hepatic fibrosis, it can be observed scar tissue or fibrosis, and in partial nodular transformation disease, it can be observed nodules, and in cirrhosis, it can be observed both features, fibrosis and nodules. There are many factors that contribute to the formation of cirrhosis. The most important ones are alcohol, chronic hepatitis B virus, chronic hepatitis C virus, and the metabolic syndrome. The mathematical model. Here I show you the interactions considered. The model consists of 6 variables: H, Z, E, C, AS, and AL. H is the healthy hepatocytes that proliferate at a rate rho. E is the struct, and the struct inhibits the carbon tetrachloride. The carbon tetrachloride damages the healthy hepatocytes to produce a damaged hepatocytes population that die at rate delta Z. The damaged hepatocytes produce an increase in the AST and ALT levels, and there is an increase of these levels because of the natural process of the body. These interactions can be written in this system of ordinary differential equations. The equation 1 corresponds to the healthy hepatocytes. This term is the production, and this term corresponds to the healthy hepatocytes damaged by the carbon tetrachloride. Equation 2 is the damaged hepatocytes, and equation 3 and 4 are the AST and ALT levels. We can see that when there are damaged hepatocytes, there is an increase of these levels. And these two terms corresponds to the elimination by the body. And the elimination is bounded in the healthy levels, AS0 and AL0. These two last equations corresponds to the pharmacokinetics of the carbon tetrachloride and the struct. The initial conditions for H was 100% because at the beginning of the experiment, the rats were completely healthy. That's why Z0 is equal to 0, and the AS0 and AL0 were determined depending on each rat. And C0 and E0 were determined by the administration times TJ. The damage and treatment inclusion was modeling as impulses according to these equations. C star-like symbol corresponds to the concentration reaching the liver tissue, and E star-like symbol corresponds to the concentration of the extract reaching the liver tissue. Model fitting to experimental data. Here I show you the experimental data measured by the biologist. There are three groups: the control, the cirrhotic or only carbon tetrachloride, and the treated cirrhotic group. We can see that the AST levels and ALT levels are higher for the cirrhotic group than the control, and the treated cirrhotic group are also higher than the control group, but lower to the cirrhotic group. These levels were measured at the just before the sacrifice. And here you can see some examples of the livers. The biologists told us that a reasonable value for healthy hepatocytes in this liver is 30%, and for this liver is 80%. Here I show you the liver pharmacokinetics for carbon tetrachloride. From this study, we can assign these values to lambda 1 and the concentration in the liver. And for the extract, we assume that the extract behavior is similar to the silymarin. Silymarin is a drug for the liver injury. And from this study, we can assign these values to lambda 2 and Emax. We try to define biologically consistent intervals. From our control group, we can define this interval. That is, this was the concentration, the AST concentration, the lowest, and this was the highest, and the same with AL0 concentrations. From this study, we can define these three intervals for rho, delta S, and delta L. And from this study, we can define this interval for delta C. And eta and kappa were free values. The parameter fitting was done using the library fmincon defined in MATLAB, and we minimize the error, this function, when only carbon tetrachloride is administered. This value corresponds to the healthy hepatocytes, 30% for cirrhotic group, and this is the value of the equation for at the end of the experiment. And the same with the damaged hepatocytes. These two terms are the AST levels measured by the biologists. I show you in the previous table, and this is the model. And when both are given, that is the extract and the carbon tetrachloride. This was the function that was minimized. This corresponds to the 80% of the healthy hepatocytes. This is the equation for the healthy hepatocytes. And this is the 20% of damaged hepatocytes. This is the equation for damaged hepatocytes. And the same with the AST and ALT levels. Here I show you some simulations. This corresponds to a cirrhotic rat. In this case, the rat is a number 4. The first graph corresponds to the healthy hepatocytes. And we can see as time goes on, the healthy hepatocytes decreases. And for this graph, we can observe that the damaged hepatocytes increases. These two graphs corresponds to the AST and ALT levels. This red point is the medition by the biologist. We didn't know at the beginning of the experiment the levels, but these lines corresponds to the healthy levels. So we can see that a value between this line is a reasonable value, and the model fits very well the experimental data. And here I show you another simulation. This corresponds for a cirrhotic rat 7. And we can see the same as the previous slide. The model fits very well to the experimental data. This graph corresponds to a treated cirrhotic rat. For this case is the rat 1. We can see that as time goes on, the healthy hepatocytes increases until 80%, and the hepatocytes, here decreases, and here increases until 20%. And the same, the healthy levels, and the initial condition in the levels are between the healthy levels. And here I show you another example. This is another treated cirrhotic rat. In this case is a 4. And we can observe that the model fits very well the experimental data. In these tables, I show you the parameters and the initial conditions in AST levels and ALT levels for each rat. All the initial conditions are between the healthy levels, and here are the parameter values. And we can observe that the variation in the parameter values is very little. And finally, the conclusions. The mathematical model successfully describes the data of carbon tetrachloride induced cirrhosis in rats either treated with the extract or not. AS and AL initial conditions are in line with our rat experiments results. All the parameter values are consistent with real biological experiments. There is very little variation between parameter values for each rat, as would be expected. And the model can be used to study control schemes of liver injury, which help biologists decide the most appropriate one depending on the purpose of the experiment. And here you can see my references. Thank you for your attention.